Hey guys, I am back with the second video of the video series on class 9th science, force and laws of motion. And in this video, we are going to solve numericals and numericals. So by the end of this video, I'm telling you, you will be super duper confident to solve any numerical problem from force and laws of motion. So what are we waiting for? Let's get started.
It says a truck starts from rest and rolls down a hill with a constant acceleration. Okay, it travels a distance of 400 meters in 20 seconds. So it says that the truck starts from rest. That means the initial velocity is 0. It travels a distance of 400 meters. That means the distance covered is 400 meters in 20 seconds. So time is 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 metric tons. So what is the mass? 7 metric tons. But we need the mass in SI unit, that is kg. So here it is given 1 metric ton is 1000 kg. So 7 metric tons would be 7000 kgs. So now here, in order to solve these problems related to motion, we will need the kinematic equations of motion on and off. So we will be making use of those three equations. So in order to find out the acceleration, we are given S, U and T. So which equation of motion will suit it the most? The second equation. Second equation says S is equal to ut plus half at squared. So from this we can say u is 0, so this will be 0 half a t squared, that is 20 into 20. So this implies acceleration is equal to 2 into s, that is 400, divided by 20 into 20. Right? So this will get cancelled, so it will be 2 meter per second square. So this would be the acceleration. Now we have to also find out, in the second part, we have to find out the force acting on the truck. So the force will be equal to, according to Newton's second law, force is equal to mass into acceleration. So mass is given as 7000 kgs and acceleration we found out as 2 meter per second square. So this will be 14,000 newtons. So this much force will be acting on the truck. Let's look at problem 2. It says a stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. So what are the values that are given here? Mass of the stone is given. It was thrown with a velocity. That means the initial velocity was 20 meters per second and later it comes to rest. That means final velocity is 0. After traveling a distance of 50 meters. So S is equal to 50 meters. So what is the force of friction between the stone and the ice? Now when will your stone come to rest? Let us suppose this is the ice and this is your stone. So when you throw the stone, it falls here and it comes to rest. Why does it come to rest? Because of the force of friction. So when will it come to rest? When the force of friction becomes equal to the force which is acting on this stone. I mean, when you throw the stone with this much velocity, there will be a force associated with it. So when the force of friction becomes equal to the force acting on the stone, then the stone comes to rest. Correct? So force of friction, when the force of friction becomes equal to force acting on stone, then it comes to rest. Right? Now we can calculate the force which is acting on the stone with the help of these data. How can we calculate this force acting on the stone? From Newton's second law, force is equal to mass into acceleration. Mass is given here, acceleration we have to find out from these three values. So we can find that from this third equation of motion. So using the third kinematic equation, so we will make use of the third equation of motion, that is v square is equal to u square plus 2as. So from this we can say 0 is equal to 20 into 20 plus 2a into 50. So this implies that acceleration is equal to minus 4 meter per second square. What does this negative sign show? It shows that the body is retarding. That is, the velocity of the body is gradually decreasing. Right? So this is my acceleration. So now we will calculate the force acting on the body. So that force will be equal to mass into acceleration. Mass is 1 kg. Acceleration is minus 4 meter per second square. That is minus 4 Newton. So what does the negative sign indicate? Negative sign shows that this force acts opposite to the direction of motion. Right? So that means this is a resistive force, the force which is trying to oppose its motion. So this much is the frictional force between the stone and the ice. Since this force is acting opposite to the direction of motion, that is why it is coming to stop. Let us now have a look at this problem. It says an automobile vehicle has a mass of 1500 kg. What must be the force between the vehicle and the road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? So we are given that the mass of the vehicle is 1500 kgs, right? And we want the vehicle to be stopped in some time. That means we want that the final velocity should be 0. It also says that it has a negative acceleration of 1.7 meter per second square. So we have to calculate the force. So here if you see, the force acting on any object is given by Newton's second law, that is product of mass and acceleration. So here mass is given as 1500 and acceleration is given as minus 1.7. So this is minus 2550 Newton. So even here the sign is negative, which shows that the direction is opposite to direction of vehicle motion. So the direction in which the vehicle is moving, let us suppose if this is the vehicle is moving in this direction, so this force will be acting in the opposite direction. And that is how the vehicle will actually come to stop. Let us look at problem 5. Using a horizontal force of 200 newtons, we intend to move a wooden cabinet across a floor at a constant velocity. Okay, there is a wooden cabinet. We want to move it on the floor by applying a force of 200 newtons and we want to move it at a constant velocity. So whenever I say constant velocity, what does that mean? Velocity constant means acceleration is equal to 0. Why? Because acceleration is nothing but rate of change of velocity with time. So if velocity is constant, that means it is not changing with time. So acceleration would be 0. So what is the force of friction that will be exerted on the cabinet? Now this is your wooden let us suppose this is the wooden cabinet and we want to move it across the floor, and for that we have applied a horizontal force of 200 Newton. So now we want that it should move at a constant velocity. So what is the force of friction that will be exerted on the cabinet? So the force of friction will be exerted along this direction. So now this will move with uniform velocity only when acceleration is 0. Now acceleration 0 implies that the net force acting on this cabinet should be equal to 0 according to Newton's second law, because Newton's second law states that force is equal to mass into acceleration. So if acceleration is 0, the net force acting on this object should be equal to 0. Now when will the net force equal to 0? When for this force there will be another equal and opposite force acting. Now from Newton's third law we know that equal and opposite forces exist. For every reaction there is an equal and opposite reaction. So this frictional force has to be equal in magnitude to this force. Therefore, the frictional force should be equal to minus 200 Newton. That means it has to be equal in value to the applied force and at the same time it should be in the opposite direction. So in that case what will happen? The net force on this cabinet would be 0. As a result, the acceleration of this cabinet would be 0, because of which it can move with a constant velocity. So here comes problem 6. Two objects each of mass 1.5 kgs are moving in the same straight line but in opposite directions. Okay, so we have two objects. Let us say M1 and M2 are the two objects which are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. So that means these two objects come towards each other, they collide, and after collision they stick to each other. So what will be the velocity of the combined object after collision? Right? So here, what are the data that is given? Mass of 1 and 2 is equal to 1.5 kgs. Velocity of 1 is equal to velocity of 2, that is equal to 2.5 meter per second. So we have to calculate the velocity after collision, right? So let us try to calculate the total linear momentum. So the total momentum before collision. So before collision, let us denote the total momentum as P1. So P1 will be equal to the momentum of M1 plus the momentum of M2, that is M1 V1 plus M2 V2. So in this case, this comes out to be 1.5 into 2.5 plus M2 is 1.5 into V2, that is again 2.5. But did you notice one thing? This V2 is in the opposite direction, right? So this will have a negative sign. So the total momentum before collision is equal to 0. Now what happens after collision? After collision, M1 and M2 stick together, right? So let us assume that the total momentum after collision is P2. So this will be equal to mass into velocity. So what would be the mass of the object? M1 plus M2, and the velocity with which it moves, let it be V. So this will be equal to M1 plus M2, that is 1.5 plus 1.5, that is 3. So this will be 3V. Now, by conservation of momentum, what do we know? From conservation of momentum, we know that the total momentum before collision should be equal to the total momentum after collision. So from that we can say that 3V should be equal to 0. This implies V should be equal to 0. That means the combined object after collision would not move at all because it will have 0 velocity. Let us look at problem 7. It says a hockey ball of mass 200 grams traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity at 5 meter per second. Okay, calculate the change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. So in this case, we are given the mass of the ball as 200 grams and the velocity with which it was moving as 10 meter per second. So initially this was the mass of the object and it was moving with this much velocity. Now what happened later? Later it got struck by the hockey stick, right? So after being struck by the hockey stick, what happened? The mass anyway still remained the same, but what happened to the velocity? The velocity changed. It returned along its original path with a velocity of 5 meter per second. So now the velocity became 5 meter per second and it returned along the original path. That means it was in the opposite direction. So therefore, change in momentum is equal to, so this was after and this was before. So the change in momentum will be equal to mv, that was the initial momentum, minus mv dash, that was the final momentum. So this will be m into v minus v dash, that is equal to 200 into 10 to the power minus 3 because it is 200 grams. So we'll convert it into kgs into v, that is 10 minus 5. So this becomes equal to plus 3000 into 10 to the power minus 3, or this can be written as 3 kg meter per second. So this would be the change in momentum in this scenario. Let's look at the next problem. A bullet of mass 10 grams traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Okay. Calculate the distance of penetration of the bullet into the block. So that means you have a bullet which is traveling with some velocity 150 meter per second. So this bullet will strike this wooden block, and after striking the wooden block, it will come to rest in 0.03 seconds. So let us suppose it came to rest at this point. So we have to calculate this distance of penetration, right? So now what are the values that are given here? Mass is given as 10 grams. Initial velocity is 150 meter per second. Final velocity is equal to 0 because it finally comes to rest. Time involved is 0.03 seconds. So we have to calculate the distance covered, that is S, right? And we also have to calculate the magnitude of force exerted by the wooden block on the bullet. So we have to calculate force also. Now using the first equation of motion, we know that V is equal to U plus AT, right? So from this we can say 0 is equal to 150 plus A into 0.03. So from this we can calculate A as minus 5000 meter per second square. So this is the acceleration. So using this we can say S is equal to ut plus half AT square. So this is equal to 150 into t, that is 0.03, plus half into acceleration is minus 5000 into t square, that is 0.03 whole square. So from this we can calculate S is equal to 2.25 meters. So that means it will penetrate, this distance of penetration would be this much. This much distance it will cover inside the block before coming to rest. Also calculate the magnitude of force. So to calculate the magnitude of force, we will again make use of Newton's second law, that is mass into acceleration. So mass is 10 into 10 to the power minus 3 kgs into acceleration is given as minus 5000. So this comes out to be 50 newtons. So here we have to calculate only the magnitude of the force. So we are not much bothered about this negative sign. Let us look at the problem number 9. It says an object of mass 1 kg traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. They both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. Okay, so what are the values that are given here? So it says that the object has a mass of 1 kg and it was traveling with a velocity of 10 meter per second. Right? So this was the scenario before collision. Now after collision, what happens? The total mass m dash becomes equal to the mass of the block plus the mass of the object, because after collision they both stick together, because here it says it sticks to the stationary block. So the mass after collision becomes 1 kg plus 5 kg, that is equal to 6 kgs. And the velocity with which they move after collision, that we have to calculate. So before the impact, means before the collision took place, what was the total momentum? Total momentum would be mass into velocity, that is 1 into 10, which is equal to 10 kg meter per second. So this part is done. Now we have to calculate the total momentum after impact. So after the collision, what is the total momentum? That will be equal to m dash v dash, right? So that is equal to 6 v dash. We have also to calculate the velocity of the combined object, that means v dash. Now from conservation of momentum, what do we know? We know that the total momentum before collision should be equal to total momentum after collision. So from this we can say 10 should be equal to 6 v dash, or v dash should be equal to 10 by 6, that is equal to 1.67 meter per second. So this is the velocity of the combined object. So now we can calculate the total momentum after the impact. So the total momentum after impact will be 6 into 1.67, that is equal to 10 kg meter per second. So I hope now you are able to understand the conservation of momentum even more clearly, because earlier I was just explaining the theory. Now you are getting how it is actually put into application. It says an object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 10 meter to 8 meter per second in 6 seconds. Okay, so you have an object of mass 100 kgs. So initial velocity was 5 meter per second, final velocity is 8 meters per second, and in how much time this increase in velocity took place? 6 seconds. So we have to calculate the initial momentum. We have to also calculate the final momentum, and we also have to calculate the magnitude of the force. So what would be the initial momentum? Mass into velocity, mass into initial velocity rather. So that will be equal to 100 into 5, that is equal to 500 kg meter per second. Now let us calculate the final momentum, which will be equal to mass into final velocity, which is equal to 100 into 8, that is equal to 800 kg meter per second. Then we have to calculate the force exerted. So force is given by mass into acceleration. So mass is given, acceleration is not given. So for acceleration, we will make use of the first equation of motion, that is V is equal to U plus AT. So from this we can say A is equal to V minus U divided by T, that is equal to 8 minus 5 divided by 6, which is equal to 0.5 meter per second square. So therefore force is equal to mass into acceleration, which is equal to 100 into 0.5, that is equal to 50 newtons. So this is the magnitude of the force exerted on the object. Let us look at problem 11. It says, how much momentum will a dumbbell of mass 10 kgs transfer to the floor if it falls from a height of 80 centimeters? Take its downward acceleration to be 10 meter per second square. So in this case, the mass of the dumbbell is given as 10 kgs. It falls from a height of 80 centimeters. That means the distance that it covered is 80 centimeters, which is equal to 0.8 meters. What is the acceleration of the dumbbell? It is 10 meter per second square. Initial velocity is equal to 0, and we have to calculate the final velocity, because we have to calculate how much momentum will it transfer to the floor. That means it will transfer to the floor only when it will reach the floor. That means the final velocity we should know. Only then we can calculate the momentum. So how do we calculate the final velocity? Using the third equation, that is v square is equal to u square plus 2as. So from this we can say v square is equal to 0 plus 2 into a into s. So this is equal to 16. So v is equal to 4 meter per second. So this is the velocity when it reaches the floor. Therefore, the momentum that it will transfer to the floor will be equal to the product of mass and velocity. So mass is 10 kgs and velocity is 4 meter per second. So this would be 40 kg meter per second. The problem says two persons managed to push a motor car of mass 1200 kg at a uniform velocity along a level road. The same motor car can be pushed by 3 persons to produce an acceleration of 0.2 meter per second square. With what force does each person push the motor car? So what's happening here? So in the first case, there are 2 persons who are trying to push this motor car, right? Such that this motor car of mass 1200 kg is moving at a uniform velocity along this road. Right? In the second, so this is my first scenario. In the second scenario, what happens? The same motor car is now being pushed by 3 persons. Now, in the first case, it was moving with a uniform velocity. That means acceleration was 0. But in this case, when 3 people are giving force to this, or when 3 people are trying to push this motor car, in this case the acceleration is 0.2 meter per second square. So we have to find out the force that with which each person is pushing the motor car. So let us first consider case 1. In the first case, what happens? Here, force given by 2 people. Since the net acceleration is 0, what does that mean? The net force acting on this motor car is equal to 0, right? That's what we studied. From Newton's second law, we know that if acceleration is 0, your net force has to be 0. Net force 0 means the total force given by these 2 persons will be equal and opposite to the force of friction, which is acting in the opposite direction, right? So we can say that force given by 2 persons will be equal to the force of friction, which will be exerted by the load on the vehicle, right? In the second case, what happens? In the second case, the force given by 3 people is greater than the force of friction. Now, since this force is greater than the force of friction, that is why the motor vehicle is moving with some acceleration. That means its velocity is increasing, right? So that means this force given by 3 people is greater than the force of friction. Now, by how much this force is greater than the force of friction? So we can say that F minus the frictional force is equal to the net force that is acting on this vehicle. So that will be equal to mass of the vehicle into the acceleration of the vehicle, right? What is the mass of the vehicle? It is given as 1200 kgs. And what is the acceleration? The acceleration produced in this case is 0.2 meter per second square. So this comes out to be 240 newtons. So that means this 240 newton is the extra amount of force which has been provided in case 2. Now in case 2, what was the extra thing? 1 person was extra, right? That means each person applies, and in the first part it says that each of the persons are giving the same amount of force. That's what is mentioned in the problem, that assume that all persons push the motor car with the same muscular effort. Therefore, we can say that each person pushes the motor car with a force of 240 newtons. Right? You understood the difference? In the first case, 2 people were there. In the second case, 3 people were there. But because of this extra 1 person, the motor car is moving with an acceleration of 0.2 meter per second square. So this extra force which is given by this 1 person is mass into acceleration, which is equal to 240 newtons. So we can say that each person is giving a force of 240 newtons. It says a hammer of mass 500 grams moving at 50 meter per second strikes a nail. The nail stops the hammer in a very short time of 0.01 seconds. What is the force of the nail on the hammer? So mass of the hammer is given as 500 grams, which is 0.5 kgs. So this hammer was moving with a velocity of 50 meter per second. Right? Now the nail stops the hammer in a very short time of 0.01 seconds. That means within a time period of 0.1 seconds, the hammer is stopped. Correct? That means the final velocity is equal to 0. So this 50 meter per second is nothing but the initial velocity, which is denoted by u. So from this, we have to calculate the force of the nail on the hammer. From Newton's second law, we know that in order to calculate force, we need mass of the object and also the acceleration with which the object is moving. So in order to find out acceleration, we have to make use of the equation of motion. So let us use the first equation. The first equation says v is equal to u plus at. So from this we can say acceleration is equal to v minus u by t, that is equal to 0 minus 50 divided by 0.01. This comes out to be minus 5000 meter per second square. So this shows that this is retardation, that is negative acceleration. The velocity of the body is gradually decreasing. So now let us calculate the force, which will be mass into acceleration, that is 0.5 into 5000. So this comes out to be minus 2500 newtons. So this is the force exerted on the hammer. The negative sign shows that the direction of force is opposite to the direction of motion of the hammer. Here comes problem 14. It says a motor car of mass 1200 kg is moving along a straight line with a uniform velocity of 90 km per hour. Its velocity is slowed down to 18 km per hour in 4 seconds by an unbalanced external force. Okay, so that means this motor car of mass 1200 kgs had initial velocity 90 km per hour. Let us convert it into meter per second so that this will be easier for us during the calculations. So it will be 90 into 1000 divided by 60 into 60. So this comes out to be 25 meters per second. The final velocity, now as the question says, the velocity slows down to 18 kilometers per hour. So 18 kilometers per hour is the final velocity, which again comes out to be 18 into 1000 divided by 60 into 60, which comes out to be 5 meters per second. Right? Now, in how much time the velocity changes from u to v? In a time period of 4 seconds. So, we have to calculate the acceleration. We also have to calculate the change in momentum. Change in momentum means final momentum minus initial momentum. We also need to calculate the magnitude of the force. In order to calculate acceleration, we will directly make use of the equation of motion, that is the first equation of motion, that is v is equal to u plus at. So from this we see acceleration is equal to v minus u divided by t, that is equal to 5 minus 25 divided by 4, that is equal to minus 5 meter per second square. So this would be the acceleration. In the second part, it is asking to calculate the change in momentum, that is final momentum minus initial momentum. So this will be equal to mass into velocity minus mass into initial velocity, which is equal to m into v minus u, that is equal to minus 1200 into 20, which is equal to minus 24000 kg meter per second. So this would be the change in momentum, and then we have to calculate the magnitude of force. So force is nothing but mass into acceleration, which is 1200 into acceleration, that is 5 meter per second square, which comes out to be minus 6000 newtons. So it only asks us to calculate here the negative sign again shows the same thing, that the force is in a direction opposite to the direction of the motor car's motion. Let us look at problem 15. It says from a rifle of mass 4 kgs, a bullet of mass 50 grams is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. I was talking about this bullet and rifle example while talking about conservation of momentum, right? So what happens in this case? Initially, let us suppose this is your rifle and this is the bullet. So initially both the rifle and the bullet both are at rest. But in this problem it says that it is moving with an initial velocity of 35 meter per second. So as soon as you pull the trigger, the velocity with which the bullet moves is 35 meter per second, right? So initially what happens? Mass of the rifle is 4 kgs, mass of the bullet is 50 grams. Velocity of the rifle is equal to 0. Velocity of the bullet is also equal to 0. Everything is at rest. Later what happens? Mass still remains the same, right? So let me convert this grams into kgs, 0.05 kg. So here also this will be 0.05 kg. But now what will be the velocity of the rifle and the bullet? Now the velocity of the rifle is something which we have to calculate. And what is the velocity of the bullet? It is given as 35 meter per second. So let us calculate the initial total momentum. So initial momentum would be m1 u1 plus m2 u2, which will come out to be 0. What would be the final momentum? That will be equal to m1 v1 plus m2 v2, that will be equal to 4 into v1 plus 0.05 into 35. Right? Now, according to conservation of momentum, as per conservation of momentum, total initial momentum should be equal to total final momentum. Therefore, we can say 0 is equal to 4v1 plus 0.05 into 35. So, from this we can say v1 is equal to minus 0.4375 meter per second. So here if you notice, this is the velocity of the rifle, and the negative sign shows that the rifle moves in opposite direction. The bullet will move in this direction, whereas the rifle moves in this direction. Now let us look at the last problem of the lesson, that is problem number 16. It says two objects of masses 100 grams and 200 grams are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second respectively. They collide, and after collision, the first object moves with a velocity of 1.67 meter per second. Determine the velocity of the second object. So in this case, what happens before collision? Let us first look at the before scenario. Before, mass of the first object is 100 grams, that is 0.1 kg. Mass of the second object is 200 grams, that is 0.2 kg. Velocity with which the first object is moving is 2 meter per second. Velocity with which the second object is moving is 1 meter per second. So what is the total momentum before collision? It would be m1 v1 plus m2 v2. That is equal to 0.1 into 2 plus 0.2 into 1. So this is equal to 0.4 kg meter per second. So this is the total momentum before collision. Now let us look at what happens after collision. Now it says they collide, and after collision the first object moves at a velocity of 1.67 meter per second. Now masses will remain the same. There is no change in mass. m1 is 0.1 kg, m2 is 0.2 kg. v1 is given as v1 dash, we can say, is given as 1.67 meter per second. v2 dash is something which we have to calculate. So the total momentum after collision would be m1 v1 dash plus m2 v2 dash. So therefore this we can write it as 0.1 into 1.67 plus 0.2 into v2 dash. Now from conservation of momentum, we know that the total momentum before collision should be equal to the total momentum after collision. So we can say 0.4 should be equal to 0.1 into 1.67 plus 0.2 v2 dash, right? So from this we can calculate v2 dash is equal to 0.4 minus 0.167 divided by 0.2. So this comes out to be 1.165 meter per second. So this would be the velocity of the second object, right? So I hope that solving all these problems would have made you understand how we apply the theoretical concepts which we studied in this chapter so far. So see you all in the next lesson.
I hope you found this video useful. If you have a feedback to share, do let us know in the comment section. Also share this video with your friends so that they can also get a very good understanding on force and laws of motion. I will meet you guys very soon with a new video and with a new topic. Till then, take care, stay home, stay safe. Bye-bye.